In this video, we will observe the reaction between the aqueous solutions of sodium hydroxide and nickel 2 chloride. To conduct this reaction, we'll need two 50 milliliter beakers from the container shelf. By taking the mass of the beakers on a balance, we'll find the mass to be 85 grams, which will be the same for both beakers. Then we will input 15 milliliters of 1 molar sodium hydroxide into the first beaker. And in the second beaker, we'll input 6 milliliters of 1 molar nickel 2 chloride. As you can see, the mass is 91.556 grams for nickel 2 chloride and beaker, which, after subtracting out the mass of the beaker, leaves the mass of the nickel 2 chloride to be 6.556 grams. And the sodium hydroxide with the beaker has a mass of 100.318 grams. And again, after subtracting out the mass of the beaker, leaves the mass of the sodium hydroxide to be 15.318. And to observe the reaction, we'll pour out the whole beaker of nickel 2 chloride into the beaker of sodium hydroxide. As you can see, there's a small green solid at the bottom, which is nickel hydroxide, and the remaining aqueous solution surrounding it is sodium chloride. If we place this on a balance, it turns out to be 106.874 grams. And after subtracting out the mass of the beaker, we can see that the conservation of mass is maintained, and the total mass of the product is 21.874 grams, as it was in the beginning.
This type of reaction is called a double displacement, which means that the ions swap atoms to form new substances. In this case, the hydroxide anion and the chloride anion swap cations to form nickel hydroxide and sodium chloride. This is different from a single displacement reaction in which one element in a compound is replaced by another. We can see in this balanced equation that 2 moles of aqueous sodium hydroxide combine with 1 mole of aqueous nickel 2 chloride to form 1 mole of solid nickel 2 hydroxide, which is evidenced by the green solid at the bottom of the beaker, and 2 moles of sodium chloride, which is the aqueous solution in the beaker.